Welcome to solverfy.
All right, we're looking at question 28.14, and we have a square wire loop with a current in it, and we want to figure out the magnetic field at the center of the loop. So first, specifically coming from these small little segments right in the midpoint of each of the wires of each of the sides of the square. So let's first take a look at the direction of the magnetic field that each of these little segments of wire are going to contribute to. So the current is going clockwise for this whole loop. And if we take a look at just one of these little segments here, using the right-hand rule, we want to point our thumb in the direction of the current. So pointing our thumb for this top segment, for example, to the right, our fingers are going to curl into the page at this point here. So this section is going to contribute a field into the page. If we do the same thing for this segment on the right, pointing our thumb down, again, our fingers curl into the page. And if you follow along this entire segment, you'll notice that for all four of these points, actually, when we use the right-hand rule, they're all going to contribute a magnetic field pointing into the page. So that makes this really easy because of the symmetry of this problem. We can just pick one of these to calculate and then just multiply our answer by 4 because each of these 4 segments are going to contribute the same magnetic field, and the direction from all of these segments is going to be the same, the resulting magnetic field. So we'll be able to just add all of these up at the end. So let's just take a look at one of these little segments, this one on the right here. So since the side of one of these pieces of wire is 10 centimeters, the center, this midpoint, is going to be 5 centimeters from the midpoint here on the right side. So our R, our distance, is 5 centimeters. And down here, I've just converted our relevant lengths here to meters so that we don't have to worry about unit conversions in the future. So to solve this, we want to use the Biot-Savart law, which I've written down over here. We have our constant mu naught divided by 4 pi, so this is just a constant here. Our current, we know, is going to be 8 amperes. Our dl is the length of the small segment that we want to look at, and that's going to be 1.2 millimeters, or 0.0012 meters. And now let's think about sine of phi. So phi is the angle between dl and r. And here r is this green line. That's our 5 centimeters. And dl is just straight along this little red line here. And notice that these are going to be perpendicular. So if they're perpendicular, the angle between them is 90 degrees. And the sine of 90 degrees is just going to be 1. So we can actually just say that this is going to be 1 here. We don't have to worry about that term. And again, our r squared, our r here, is going to be 0.05 meters because that's the distance from the point to the segment that we're considering. So this is going to be the contribution from just one of these little segments. And remember, we have 4 of them, and because of the symmetry here, all we have to do is just multiply this entire expression by 4 to get the total magnetic field. And when we do that, we're going to get that B is equal to 2.88 times 10 to the minus 6 Tesla. And again, the magnetic field is pointing into the page.